So, good morning everyone. It's Prince JG Jimena, the first presenter for this topic. So, we parted the topic into three parts. I'm going to discuss the first part, and Alan J. Alsanose will discuss the middle part, and last will be discussed by Miss Ara Tibay. This topic is all about tectonics and weathering, continents and oceans. Plate tectonic theory, the Earth is roughly spherical, although it is 42 kilometers shorter if you travel around the world via the poles, compared to traveling around the equator. The 1,200 kilometer thick inner core of the Earth is solid. The inner core is surrounded by a thick layer of liquid iron-rich material, forming the outer core. The next layer is called the mantle, along with the overlying crust is called the lithosphere. Large continents form a cold and rigid crust, mainly made from granite rock around 35 to 70 kilometers thick. However, the rock on the ocean floor is made from basalt and forms a thinner 6 to 10 kilometer thick crust. Importantly, the density of the rock on the ocean floor is slightly greater than that of the continents. The proof for plate tectonic theory has surprisingly only emerged in the last half-century. Earlier, explorers had noted that the shapes of the continents seemed like they would fit together, and there had been scientists who studied fossil evidence during the 19th and early 20th century. Detailed maps of the ocean floor show that there are large mountain ranges running through the center of the world's major oceans, and that there are valleys in the middle of these mountain ranges. It was also found that the deepest parts of the oceans are located very close to the edge of the ocean rather than in the middle. Within the mantle, there are massive net currents of liquid kelp molten by radioactivity within the Earth. So, do you have any questions, clarifications, and violent reactions? So, if none, let us now listen to the next presenter, Alan J. Alsanose.
Thank you, Mr. Jimena. Good day, everyone. I am Alan J. Alsanose, and I will be discussing weathering, erosions, and different types of rocks. Let's all imagine we are standing in front of a magnificent mountain range. Those majestic peaks didn't form overnight. It took millions of years of relentless weathering and erosions to carve these natural wonders into what we see today. Alright, weathering and erosions. Weathering is the physical breakdown of rocks, whereas erosion is the transportation of the weathered materials. Mountains that are built by tectonic processes are eventually worn down by weathering and erosion. So, meaning, weathering is the process by which rocks and materials deteriorate over time due to exposure to atmospheric elements such as wind, rain, and temperature fluctuations. This process is like a nature's sculptor, shaping the Earth's surface and creating valleys, canyons, and riverbeds. However, it's not just about creating stunning landscapes. Weathering and erosion play a crucial role in maintaining the balance of ecosystems and preserving our planet's overall health. Moving on, these are different types of rocks, which are igneous, sedimentary, and metamorphic. These rocks are formed when molten lava cools and solidifies. The temperature at the time of formation, the mix of minerals present, and pressure all interact to create varieties of these main rock of types. Igneous rocks. If the rock is able to cool slowly, then larger crystals may grow, producing a coarse green rock such as granite. These are formed by volcanic activity. When magma, which is molten rock beneath the Earth's surface, cools down and solidifies, it forms what we call igneous rocks. Just imagine the immense heat and pressure involved in this process. There are two main types of igneous rocks, intrusive and extrusive. Intrusive rocks form below the Earth's surface and have coarser textures, like granite. On the other hand, extrusive rocks cool down quickly after being released onto the surface, resulting in finer textures. Moving on, to the metaphoric rocks. Metaphoric rocks form through the partial melting and reforming of existing sedimentary or igneous rocks, often under high pressure. So, these rocks tend to be more resistant to weathering as they are harder than other rock types. Metaphoric rocks like marble and slate have unique and mesmerizing patterns. These rocks go through a transformative journey themselves. They are formed when existing rocks, whether igneous or sedimentary, are exposed to extreme heat and pressure, fundamentally changing their structure. Now let's move on to sedimentary rocks. These rocks are like history books, preserving the stories of our planet for millions of years. Sedimentary rocks are produced by the weathering of rocks followed by subsequent erosion and deposition of material. So these rocks are often contain a record of the physical conditions present when the rocks were deposited, including fossils. In fact, some rocks such as chalk or coal are almost entirely made from the remains of animals and planets. The rock cycle means that all rock types can convert into other types. All rocks can be melted and cooled to form igneous rock. And all rock types can be weathered and eroded to form layers of sediment that can be eventually become sedimentary rocks. Rocks are not just dull objects lying around. They are pieces of our planet's history, showcasing the immense power and beauty of nature. Exploring the different types of rocks, from igneous to sedimentary to metamorphic, can open up a whole new world of understanding. I hope you understand these different types of rocks. With that, here now Miss Tivay, the next presenter.
So thank you Mr. San Jose for introducing me. Again, my name is Arshal Estivay and I'm here to discuss and introduce to you the different types of weathering. So what is weathering? Weathering is the breakdown of rocks by physical and chemical processes. These processes can happen individually or in combination, and they can also involve biological actions. Different rocks break down at different rates, leading to distinct landforms like headlines or prominent rocks in flat areas, such as Uluru in Central Austria. So as you can see, here's the picture of Uluru in Central Austria, where one type of rock erodes faster than other nearby. So let us now discuss the physical weathering. Physical weathering transforms rock by breaking it into smaller fragments through mechanisms such as freeze-thaw, salt weathering, and thermal cracking. So here's what happens during physical weathering. We have this what we call frost action or frost wedging, wherein water can enter cracks or pores in rocks, and when it freezes, it expands, creating pressure within the cracks. When the ice thaws and refreezes, it can widen and deepen these cracks, eventually breaking the rock into smaller fragments. So overall, physical weathering is a vital part of the rock cycle, breaking down rocks into smaller particles that can then undergo chemical weathering or contribute to the formation of sedimentary rocks. It's an ongoing natural process that shapes the Earth's landscape over long periods of time. So let us now talk about the salt weathering. Salt weathering is where salts within the environment form crystals in small cracks under desert conditions. So these salts, often carried by water or present in the soil, infiltrate the cracks in rocks or structures. When the water evaporates due to high temperatures and low humidity, the dissolved salts solidify and form crystals within these small spaces. As the crystals grow, they exert pressures on the surrounding material, gradually causing it to crack, break, or disintegrate. This process is particularly pronounced in dry, desert-like environments where evaporation is rapid and salt concentrations are relatively high. We also have this crystallization that happens when the temperature rises, promoting the growth of salt crystals. When moisture is introduced, like from coastal fogs carrying sea salts, the volume of the salt increases. Over time, this process can contribute to the breakdown and erosion of rocks and structures in these environments. So here's the picture of rock caused by salt weathering. Let us move on to the next slide. Thermal weathering may also be important in deserts where daily temperature ranges may be high. The rocks in these areas experience consistent expansion and contraction due to these temperature fluctuations. Various minerals within the rocks expand differently when heated, creating internal stresses that gradually weaken the rocks and loosen particles. In extreme cases, rocks can crack under the stress of this expansion, especially when exposed to a heat source like a fire, highlighting the impacts of this temperature-induced stress on the integrity of the rock structures. So now let's move on to chemical weathering. Chemical weathering, rocks are made up of bases, silica, and sesquioxides, which means in chemical weathering, the water serves as a solvent that gradually dissolves the components of rocks. Rocks consist of bases like calcium, magnesium, sodium, and potassium. Silica and sesquioxides, primarily aluminum-based. Silica is less soluble than bases but more soluble than sesquioxides. During weathering, the proportion of bases in rocks is reduced the most, followed by silica. As rocks are exposed closer to the surface, the atmosphere aids in mineral weathering. Atmospheric gases like oxygen, water vapor, and carbon dioxide play a role in weathering. When rainwater with dissolved carbon dioxide interacts with rocks, it forms a weak carbonic acid, contributing to the weathering process. Climate change factors such as intense rainfall, warmer temperatures, and higher carbon dioxide level can increase chemical weathering rates. The carbonic acid reacting with rocks in the weathering process produces dissolved chemicals that are carried away in solution. This can result in the transfer of carbon dioxide from the atmosphere to the oceans through river channels, potentially acting as a negative feedback mechanism on climate change. In addition to natural processes, vegetation roots introduce organic acids into the soil, aiding in the extraction of essential nutrients for plants and contributing to soil weathering. Soil-dwelling organisms like earthworms pass soil material through their bodies, both chemically and mechanically altering it as they extract nutrients. Overall, these processes collectively contribute to the weathering and alteration of the Earth's surface over time. So if you don't have any questions or suggestions, this will be the end of our presentation. Thank you for listening.